Hello ladies and gentlemen, my name is Decryption and I hope you are well. In a previous episode, we looked at breaking down a common game dev word, inheritance. It's a great video if you don't know what inheritance is in Unreal or in real life. We also cover that too with dogs. However, in this tutorial we're going to break down another common programming term, scope. We're not talking scope creep, we will cover that briefly just because it's got the same word in it, but specifically scoping, how you can hide variables and lock them down who can access it. So let's get started. So as per last time, we are going to start in the drawing thing because it was good fun and a lot of people enjoyed that. What is scoping? We will cover the difference between scope and scope creep, because they are essentially not even the same thing, but they contain the same word, scope. So scope is what we're going to be covering today. That is, who can see what variables. See, there's a guy with binoculars, look, he's looking at the name, but we've built a brick wall, he can't see it, blocked. That's scoping. Essentially, what variables you can and can't see. Scope creep is where you have a list of requirements for something to be done. So you might have 2, 3, 4, 5. 5 things for this task project to be completed, right? Scope creep is where this slowly, typically, starts to be increased. So you get down to task 3 and they're like, oh, wait, we forgot task 6. Can you do that as well? So you're like, okay, sure. And then you get to task 4, then they go, hey, no, we forgot task 7. Can you do that as well? Sure. You've essentially scope creep twice now because we've agreed on this one and you've gone 2 more tasks. Sometimes it can be really simple, like, oh, hey, can it be red instead? Sure, that takes 2 seconds, I can do that. Other times it can be absolutely huge. Oh, hey, we need this entire new combat system. Well, that's going to take months of work. And then you have to make the call yes or no on that. And unfortunately, in all cases, it normally ends in a really awkward conversation of you saying no. Scope creep is completely different to outside of this, so don't think they are the same thing, but they are used often in the same area. So even though you're designing it via the scope to create the variables and everything, scope creep is just the general design philosophy. So we don't need to worry about that. Let's actually get into scope then. What is scoping? What is scope, or the scope of a variable, a function, a class, something like that? So a scope essentially is who has access to this, who can see it, who can use it, who can set it, all stuff like that. So you very well may have heard the terms public and private. They are the 2 most common ones. Now for all you developers out there, yes, I know there are a lot more. We're just covering basic ones for now. We'll get into the more complicated ones later. But public and private are 2 scope types, and it's exactly what it sounds like. Everybody can see it. Greg here, Even here can see it, Dan can see it. Everybody can see this variable and everything that's public. Private is specifically the person who created it. So Ivan and everybody can't see it, so if they try to look, they'll be blocked. It'll be invisible to them. But private is typically you are the only one who can see it. There you go, there's you. I've added you into the chat, look. And you are the only one who can see this. Nobody else can see it. They are essentially non-existent to you. You can see the public variables because they're public, but you can't see the private ones. So often, in Unreal, when you're designing a blueprint, you will create your variable, so name, and you'll set it to a type of string. At this point, you don't do anything else. That, by default, is treated as public. Everything can see it, and we can test this out. If we come into Unreal, let's just create another test folder, and in here, I'll create a blueprint, BP public scope, and we'll open this up. So in here, we'll create a variable, my test variable. And it's a boolean, so we'll compile and save, right? We can actually see that from other blueprints. So if I come and create a completely different blueprint, we'll set it to a type of actor, BP underscore other actor, and we'll load it up. by default, let's just cast to that so we can actually just get an example of it. So we'll cast to BP public scope test. And if we drag off of this, we can access all of its public variables. So I forgot what I called the variable. There we go. Get my test variable. So we can see we've got the get and we've also got the set because it's a public variable. Everybody's got access to it. And by everybody, I mean scripts in your game. It's not like somebody down the road instantly knows you've created the public test variable. Everybody script-wise in the game has access to it. Any actor, any component, any C++, they know this variable now exists if they go to it. So anything can set it, which is something we'll come back to shortly. However, private ones are completely locked down. So if I grab this variable in an Unreal, tick it as private, it will no longer be able to be accessed publicly. It will be private only, meaning only this blueprint can see it. Nobody else will be able to access it. So we can test this. So back in Unreal, we've got this, it's compiled, right? We go back to the public scope test and we will select the variable and come and tick the private checkbox here and we'll hit compile and save. But if we come back to the other actor now and if we hit compile, you'll see it will allow it, but that's just Unreal being buggy. Delete the variables off and you search for it again, get test, you will see we can no longer access it anymore because it's private. Even if the entire blueprint is called public, the variable itself is marked as private. It's not enough to just move it to a private category. That's just a category called private. It means nothing. You'll often see people move a variable into private, but they won't tick it as private. So it kind of defeats the purpose of it unless it's private, as in you can modify it. We don't recommend it. The point is tick private and then it'll be hidden. And that is public and private. You might think, well, what's the point of this? Private variables are great for temporary holding of data. So for example, I've got this blueprint here, which we made in a tutorial for a jail cell. It's basically a model of a jail with a door on it, and then the door opens and closes. It's got a bunch of variables on it. This jail cell opens the door via a timeline. You'll often see people do this. But for a timeline to work, when you're lerping between two values, you need to know the start of it and the end of it. We've created private variables in a category of private, which should be ticked as private, which means nobody can change the starting rotation except myself. And to test this, we can come back to here, we can cast to BP jail cell, and you'll see the variable was called starting rotation. If we get off of this and do get starting rotation, it doesn't exist. Because it's a private variable, it's temporary. Only that actor needs to worry about it, no other actor needs to worry about it. Equally, characters in cell look isn't marked as private. It's in the private category though. But back in here, get characters in cell, you can see you can just access it. Even though it's in private, it's not. That's not the scope of it. It's not a private scoped variable. So you might think, well, what's the point of it? Does it matter? Yes and no, really. Does it affect your end game? No. Will it make it any faster or slower? No. It all compiles down to binary. It doesn't really care what it is going to be. However, it makes it easier in the editor for developers and you to not change bad things or things you shouldn't be editing without a warning. That's what it is. It's a warning sign. So for example, this starting rotation here, if I event begin play on this, got the nearest jail cell actor and went, hey, change the characters in this cell. Let's set this and we will say there's one character in this. There we go. We've done one character, right? Ignore the errors. Yeah, something like that. We've basically changed this private variable and we've added a character to it. Which means when this game runs and it starts trying to add characters into the cell here, it's going to error because the character was already there. Which means none of this logic's going to run. Because we've changed a private variable, nobody needs to know what characters are in this jail cell except the jail cell. So we need to mark that as private to stop people doing that. And that's all it is. It's really just a preventer to stop you changing things you really shouldn't be changing. And it helps you guide into it. Because you might say, hey, won't the character who's in the jail need to know what jail they're in? You are absolutely right. That is a case. but we can build in doors if you wish to it. So what I mean by that, if we have the jail cell here, and that's got the characters in cell, right? And that's an array. If that's public, you can edit that. Your NPC can edit that. The AI state tree can edit that. And I'm not saying they'll go off artificial intelligence and edit it. If you code it in, they can edit that. So if you code something on your NPC to say, when they reached a player, add them to the CIC, you've modified it, right? Or if the AI state tree does it. But you run into an issue where if your quest wants to get the CICs, and you find out there's 3 in there, but there's only ever meant to be 1, well, you've now got to do loads of debugging to figure out where that came from. And when you look at this and go, well, who's got access to this? Everyone. Everyone's got access to it, which makes it really difficult to figure out who's broke it, who's changed it. You could search for references on this and see, hey, you've got it, okay, I'll add a print statement, you've got it, add a print statement, you've got it, you shouldn't have got it, but I'll add a print statement, tick, 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 okay, it was this one. It's a lot more work for something that they shouldn't have changed in the first place. You could modify this and make it private. You can't edit it, you can't edit it, you can't edit it, and the quest can't get it either. You now have full control over this and you know what's editing it, and that's the jail cell itself. So that determines it. But what if you need to get that variable, even just to read it? Well, this is where you've got 2 options. A different type of scope called Const, which means constant. It means you can't change it. You set it once and then you never change it. That means you can't change it after the first setting of it, which is a common confusion. People often think const means you can't ever set it. No. You get to set it once, then that's it. If it's already set on default, so if I go const name equals Dan, then that's a setting. You can't change it after here. If you set name down here, it will error. If you don't set it here, so you set it to nothing, then you will be able to set it once. Const just means you can't change it after it. That is one way you can do it. Then you can make const public. You can make const public. You can access it from anywhere you want, but you can only ever set it once. That's not great for a jail cell where you want to go in and out of it potentially. And also, Unreal doesn't give you the ability to do const variables. You can in C++, you can't in the blueprints because it's a bit scope creep for blueprints. It's not part of what the project needs. So the other option is to create doors to it. So I did a video a while ago on interfaces. If you've not seen that one, go and watch it. It's a great read. But you can essentially create doors or holes, if you wish, using an interface to say, hey, just give me this data. So instead of all these characters having direct access to the jail cell, we can mark the variable as private. So this one will be private. And then we could create a door here, or an interface function where these can go, and this will say, give me CIC. And all this function does is get this variable and return it. That's all it does. Gets the variable, returns it to people. So now all of these can access this variable, but they can't set it because it's just a variable they've been given. If you want to add it in, so you have a set function as well, you absolutely can. So read and set. Now you might be thinking, again, why would you want to set it? Just make it public. This gives you the ability to control the flow of data, which is exactly why scopes are so powerful. Let's break it down a bit. Let's make the basic door example to read the private variable, and then we'll come back to this. So in my public scope test, we have my test variable, right? Let's make it something a bit more interesting. Let's just do an integer. This variable is private. We cannot get this from here. So if we just do here, get all actors of class, let's do public scope test. We'll get the first one. And in here, we can't get the test variable. So let's add a function. You can use an interface. You can use an event or a function, anything you want. For time, I'm just going to create a basic function on it because I'm already semi-casting to it. But if you're doing it properly, you'd probably use an interface. But on here, let's create a function. And I will call it getMyTestVariable. Call it anything you want. You call it Bob if you really want to. But typically the convention is get and whatever you're going for. If you're getting multiple variables, so if you've got name, damage, speed, you could say get character's details and just return all of them. But in this case, we'll do get test variable, and I'll simply output the my test variable. And you'll run into some issues if you call it the same thing. So I'll just call it read only, for example, and it'll be a type of integer, and we will set the variable there like that. So because this variable's private, itself can access it. The other actor can't access it, but now I can run the function get my test variable, which will give me the variable. I can't set this at all. It won't let me set it because that's not how it works. It's a read-only variable. And this is our doorway into it to see what this is. But then what if I wanted to set it? Which is something we've just discussed. And this is where the power of scope comes in, which is why when you understand it, it changes your entire gameplay so you can create an efficient framework. So what if I want to say this variable here cannot go above 10? If it goes above 10, game over. If I make it public, and just like in here, you, NPC, assist, quest, all edit it, we've got to check every single time these change it if it goes over 10. So you set the CIC, check the variable, do the work. This one, check the variable, check it, do the work. You've got a lot of checking there, and all it takes is for one individual to set it and then not check it for you to have a bug in your game where it breaks it. That one simple thing like that. Whereas if we scope it and give it a door or a function that sets it, we can control everybody to do it. Just like we just did, we'll create another function, set my test variable, and all it will do is input the variable that we're trying to change. So we'll call it my new test variable. It very well may be just that. If you do just that, yeah, sure, it's a bit redundant. But now we've got every single actor in the game all funneling through this one function, meaning we can say, hey, if this is more than 10, then we can, I don't know, destroy the actor. We can blow it up. There we go. Which means this one here can't set that, but we can absolutely drag off of this and now do set my test variable. And every single time we call this function, it will always run this code. Every single time. Which is where scope is so fantastic. We have now locked this variable down. It is a fully used game variable, not a temporary variable. But we've locked it down in a way where no matter how many scripts or actors access it, they will always run this check. If you have used something like the gameplay ability system, this is an image I showed off in the last tutorial where we did it. This takes high control over scope and your attributes. So in the gameplay ability system, you have something called attributes. That's your health, your speed, your damage, your max health, your mana, your stamina, everything like that, right? You can't change those variables directly. Doesn't let you. It's all locked away, so you can't do it. I believe you can do it in the C++, but the understanding is if you have access to C++, you're more confident in what you're doing with it. But they give you doors or methods of changing those attributes through specific means that you can track. So for example, they use effects here, so apply effects. In this case, it would be activate the ability fire damage, hit the target, apply the effects of burning. That burning effect reduces your health. Your health attribute can't be changed anywhere else, just effects, which is the doorway pattern of creating it. It's a private variable that only effects can edit, which is this essential template we've done here. Now you'll see this in so many different forms. I've just done a super basic example of here of changing an integer. But interfaces work exactly like this. You'll see me do it in so many of my tutorials. If I go to my game instance, I've got an interface with tons of functions on it that half of them just get data and add data. It controls the flow of data, so I can do extra things if I need to. So for example, I've got this function here, get activated cheats. This just returns this activated cheats variable as a boolean, which is a different way of doing it. You don't necessarily have to return the boolean. So I've got get activated cheat here, and you pass in the cheat. It doesn't tell you the list of activated cheats, it simply tells you if it's active. Because nobody needs to know the list of every single activated cheat. You might do, in which case create a function for it. However, in my case, getActivatedCheat just returns whether a cheat's active or not. so it limits who can access it. There is also add activatable cheat, which simply adds to it. You might think, well, that's a bit boring, why don't we just make that public? And you absolutely could. But then I didn't want people reading it unnecessarily. So I locked it down and said, hey, you can remove it, you can add to it. You have to go through these means. That's the only way you can access it. There is other stuff I can do here. So I can say after any cheat's been added, print out some text. After every single cheat. Or show the UI, play a sound, log the save game that the cheats have been enabled, like they do in GTA games. If you enable a cheat, it permanently locks on your save game. You've used cheats. That's stuff you can do when you redirect the flow of data. So when everybody can access it, you haven't got a clue what's going on. But if everybody is funneled into one area, you can control everything from that one pinpoint. And that's scoping. It is changing how variables are accessed, who can access them, and what can be done. Now this is where we get into the little bit more complicated ways. Because there are also public and private, but there are levels of public and private as well. So what I mean by that is you have the public and private, right? But there are levels to this. So you have classes, which is like your blueprint class. You have structs, which are your structures, so your data assets and stuff like that. You have events, often known as methods as well, or functions. You know what I mean by functions. These individually can have public and private variables on them, but they can also access private variables from each other, because an event can sit inside a class. That class has private variables, but the event is part of the class, meaning it can access it. But what you've also got, event level variables, which stops other events from seeing it. So what I mean by this one is it's a bit harder to show in blueprints. It is possible. It's a lot more common in C++ and coding languages. But in my other actor, if I create an event, and we will call it test, I will give it an input of my test here, right? If I create another event down below called test2, I cannot access that my test variable. If I drag over here and do my test, I cannot access it, because that variable, technically public, but it is accessed specifically in that event. So that is called an event or a method or a function level variable. It's a whole scope on its own. It's basically a private variable inside itself. Nobody else can access it. If I was to add a branch down here and connect that to that like that, I have no idea what that will even do, which is why it's a bit tough to explain in Unreal blueprints. But this, in theory, is never going to work. And if it does work, it will basically call this function like that. So I'm guessing it will do test1. I think it'll do something like that. It just gets messy. But basically, you can't do that. You can't access my test. Other variables you've seen like this are for each loops. So in here, look, we're getting a list of all the actors and we'll for each loop over them, right? Everything we connect after this is technically inside this for each, which means it's scoped to the for each. Only the for each and things using the for each can access it. So if I drag off loop body and print out the array elements display name, that will work because that print string is inside the for loop. However, if I do the same thing on completed, well, it's no longer inside the for each loop because it's outside of it. It's after the for loop is completed. So you can't do that. That's outside of the scope of it. So what I mean by this is easier in programming, in this function here, you can already see we've got a const variable here. So this means after this variable is set, we can't change it. That's one we discussed earlier. So if I do data equals null pointer, it will error look because you cannot assign to a read-only type. It's constant. If I get rid of that, ignore the other errors, this will now allow it to be set look. It's complaining about something else, but it's not constant anymore. We can edit it. So that's a const variable. However, if I come in and define a basic array, so we'll say integer array, my test equals, and after a slight reboot, because my computer decided to crash, we'll do it in the Unreal way, t array integer my test, and it's got 5 examples, right? So we've created an array of an integer with 1, 2, 3, 4, 5 as the properties. If I come in and do a for loop, so for, and you can see it's automatically filling it out for me, which is fantastic. Int I, yeah, that'll do. So this is a basic for loop in every programming language you can think of, essentially. Every programming has for loops. But we are basically saying for, and then between these brackets here and these ones here, that is the scope of this for loop. So we're saying create an integer called I, and it's set default to 0. I is less than the amount of items in here, and then we increase I each tick. So what that's basically saying is inside here, come in, set I to 0, and then once we finish, set I to 1, 2, 3, 5, because we've got 5 items, that's it, done. You'll notice inside here, we can do I equals 3. We can set that in there, because this I variable is inside the scope of this for loop. If we move this line outside of it, it will error, because it doesn't know what I is, because I is inside the scope of this for loop. You'll also notice if we come and set it to const, it will error because it can't set itself, but also we can't set a constant variable. So that is public, private, event level scope, class level scope, and by class level, I mean if we come back to base attributes set.h where you set variables, on here I've got on max health changed, which means inside here I can do on max health changed equals null pointer. I can set it to null for whatever reason. It'll say you're not allowed to, you can. That's just an error with setting it, but that is letting me set it. If I come and set this to constant, like so, it will now error because I'm trying to change a variable that's read-only. So that's the constant level. What I can also do, you can see in the C++, this is inside the public category. If I come and set this to the private category, everything under here is now private. Ignore those errors. It's just saying it's redundant doing both. But that's private. I can still access it from here, look, but I won't be able to access it, say, from here. So in here, you can see I cannot access max health change no matter what I do. It won't let me access it because it's private. If I come and set this back to public, giving the public successor, I would be able to access it again. If I knew C++ better. Let's revert all these changes so I don't freak out when it builds. So that is public, private, and const, and event and class level scoping. But there is one more level that we do need to discuss, and that is virtual or protected. Protected is to do with children and inheritance. If you mark a variable as private, but then you make a child of this class, that child will not be able to access that private variable because it is private. It is private to that class. Nobody can access it, even children. However, if you want a variable that nobody else can use, but the children can use, then you'll set it to protected, which is not an option they expose in Unreal blueprints that easily. So I can't actually see it at all for a protected setting. You can see it on functions. So when we come here, you can see you've got a protected and a private. Private function, nobody can call it, just like the variable. But we don't want that. Protected means children's of this one. So if I come and make a child of this, I can call whatever that function was called. So I can do get my test variable. I can call that function because I'm a child of it. That's fine. But other actor here, which is getting it, will not be able to call it. But the other actor, which isn't a child of it, will not be able to call that function because it's protected by its parent, essentially. If I come back and make this function private, nobody will be able to access it, including the child. So if I delete this and do get my test variable, you see it's gone because the private has locked it out. And that's pretty much all the scopes you kind of really need to know in Unreal. So you have public variables, which are accessible to anybody who wants it. You have private variables, which are accessed to you alone. Nobody on Earth is ever going to be able to touch that variable. No actor, no blueprint, no code, no struct. Only everything you have and anything inside of you. Then you have protected, which will stick onto the bottom because Unreal doesn't expose it for everything. It really should. And that is only you can access it and any children of you can access it. And that is scope in Unreal and general programming. That's it. It sounds more complicated and you don't really have to worry about it going, oh no, I'm going to have to rethink every single variable. No. It's not going to change your game and make it 60 FPS if your game is not running at 60 FPS. It's not about performance at all. It's about controlling the flow of data in your game and building a framework so you can't break things. So for example, We all know I'm a big fan of the Narrative Tales plugin. I use it in every single game I've done, every tutorial. It's great, right? The way the core of this works is it has one master array which stores everything. Every dialogue, every quest objective, every completion in one massive array. But it locks this array down so you cannot access it. Even in C++, I believe it's locked down there as well. But it has these helper functions that give you access to the specific data you need. Imagine walking into the FBI building. You're not going to get access to every single thing in the entire building, are you? You don't have clearance. It's private. But if you make a request for it, or use the door, so the reception in this case, they will give you the specific data you need. And it's the same with narrative. You can only get the quests and the data via the specific means, or in our case, public or protected functions depending on your level. That is scope. All you have to take away from this one is the next time you're designing something, you create a variable, just take that little second to think, does any other blueprint need to access this variable? If they don't, mark it's private. Or even be a bit safer, mark it's protected, just so children can access it. If they do need to access it, think why they need to access it. Are they going to be changing it, or are they just going to be reading it? If they're reading it, make it private and add a helper function, a doorway that we discussed already. If they actually need to set it, think one more step. Why do they need to set it, and what is the action of them setting it? So if I have a blueprint here with a variable of C on it, and D, A, B, C, D, C, E, all need to access this variable and set it, what's the action of them setting it? 90% of the time, if a variable is set, something needs to happen. It might not be immediate. It might be when they reach down this path down here 2 hours later in the game, now that variable is used. In which case, make it public, let them set it. But 9 times out of 10, setting a variable or calling something needs to have a reaction. So just think, next time you create a variable, what does it need to do? Change its scope, and you'll have a better, more safer game dev experience. One thing I was thinking as well is in Unreal, if you right click, millions of variables in here. Every single function and variable that you have access to is all available in here. This is a very, very long list, right? But this is only giving you access to things in your scope. So all of this is only everything this one blueprint can access, which seems like a ridiculous amount of data, and it is. It really is. Some of it, I'd argue, that you don't need to be this global, like Ultra Dynamic Sky. They have global functions to let you call all of this data, because they have locked down the system and given you multiple doors or functions to access this data. For my game, I know I don't need this much data in here, but it's a plugin, so I'm not going to change it. If you untick this context sensitive, that basically opens up and says, hey, what is this blueprint allowed to access if they perform some extra actions? So for example, public scope test, I've got my get test variable public function. In other actor, I can't just right click and do get test variable because I'm not referencing it. So this IntelliSense is saying, hey, I don't know what you're accessing. This context sensitive, if you untick it, it's saying, hey, you can access this. If I hit compile, it will error and say, I don't know what to do with this. And it's going to need me to give it access to what it needs to know, and then all of a sudden, I can now access it, look. Equally, if I pre-give it the data, I've now got access to everything inside me and inside this blueprint. So I'm combining the two into this list here, meaning I can do get test variable and it gives it. You'll notice if you ever untick context sensitive, Unreal will lag. And look at the size of the scroll bar. So here, it's about, what, we'll say a quarter of the way down. If I tick it, look how much smaller it is. How many variables you have access to is insane. But that, ladies and gentlemen, is scope. So all you need to take away from this, if somebody says what scope is the variable, it's private scope, you can't access it, or something like that, that's what it means. Who can access the variable, in what means, how it's locked down, and everything like that. If I've missed any that you think I should cover, please let me know below and I'll cover it in another video, or we'll add it into a comment if it's an easy one to explain. There are tons and tons of different ones. This is what I said at the beginning of the video. Scopes, depending on the languages you go to, And types are so vast. There are so many different ones you can access. Internal, private, public we've covered, virtual we haven't covered, but that's just overriding. So essentially, this is a child of BP public scope test. If I come in here and go to the override, I can see my get test variable. I've just overridden it. That's virtual. In Blueprints, you don't need to mark it as virtual. In C++, you do, but all it means is something can override this function. And this one is just calling the parent, so there's no point to override it. But I could change this and just say, hey, always return a 5. So if I call this function on this one, it's always going to return a 5. If I call it on this one, it will return the actual variable. That's virtual. And then you've got public and private inside functions, events, macros is something we've not covered before, all sorts of different there. But that is the basics of scope. Public and private are the key ones you'll use, and protected is a nice sprinkle on top. So there we go, ladies and gentlemen. Scoping in Unreal. Little bit more complicated to explain than the inheritance, but it's not game changing. Inheritance is going to fundamentally create your game. Scoping, you can mark everything as public, but it's not going to matter. It's not going to change the end game at the end of the day. So there we go. I hope this helped. If you've got any improvements, please let me know below. Thank you for watching. My name is Decryption, and I will see you next time.